make sure you read the directions. Just because you see something like this doesn't mean you do what we're about to do, because there are other things you could do, and you're going to see that today. But it does say find the general solution, so that's what we're going to do. First step always, separate the variables. So I think the best first step here would be to divide both sides by y squared and multiply both sides by dx, giving us this right there. We talked a little bit yesterday about why I did not divide the 6 over. I didn't divide the 6 over simply because I think it complicates the thing that I'm about to finish with. So I'm going to leave it over there on the right-hand side. No harm if you do bring it over. I think it's just better to do it this way. Once you've done this, you might want to rewrite a little bit. You'd write y to the negative 2 dy equals 6x squared minus 18 dx. And remember, if you don't separate the variables, you get nothing. So please take the time to make sure you do it right. If I had $1 for every time somebody messed up some like y to the negative 2 or divided by y squared or times y squared or whatever, I would have enough money to buy you all burritos for sure. Or at least half of you burritos, something like that. A good number of burritos. Okay, so once you have separated the variables, we're going to find our antiderivatives. They would be negative y to the negative 1 equals 2x cubed minus 18x plus c. We talked a little bit yesterday about why there's a plus c on the x side, but not a plus c on the left side. There technically is a plus c on the left side. We're just subtracting it over and subtracting it from the other c and getting some other constant. This is the customary practice to do it this way. Final step would be to solve for y. You could, multiply both sides by a negative, perhaps. So it'd be y to the negative 1 equals negative 2x cubed minus 18x minus c. But isn't minus c just the opposite of some unknown constant? Oh, sorry, positive. I was already thinking about my c and I messed up. Thanks for pointing it out. So I'm just going to put plus c again because the opposite of some unknown constant is just another unknown constant. The final steps might be some tough algebra. This is kind of where we finished last time. I think maybe you could flip the y down, so it'd be 1 over y equals negative 2x cubed plus 18x plus c. Any suggestions from here as far as what you would do to get the y by itself? You cross multiply? Sure. So that would be 1 equals, parentheses, negative 2x cubed plus 18x plus c times y. And then after you cross multiply, you would maybe divide, yeah. So it would be 1 over that. So 1 over negative 2x cubed plus 18x plus c. That whole thing would be equal to y. There'd be other versions of that answer perhaps, but that's a good one. Okay, so let's see here. Plus c characterizes general solutions. Where we're headed next, of course, is we're going to be given enough information to find the c, right? So we're going to call these particular solutions. We've done this a little bit already. We're going to hopefully finish with a problem that has been deemed legendary. We'll get there hopefully today. Okay, do you guys have any questions at all from yesterday or the last 5 minutes? Okay, fair enough. We'll flip over. Let's take a look at the next piece where we can actually find the c. Okay, so here are the directions that you would see something like this. Find the particular solution using separation of variables. It might not even say using separation of variables. It might just say find the particular solution given the initial condition or something like that. Just know that if you are tasked with finding a particular solution or a general solution, you've got to show separation of variables, even if it doesn't say show separation of variables. Okay? I'm putting it up there for emphasis, not for a pattern. Okay? Please make sure you understand you've got to do that. So let's practice this real quick. Any thoughts on what we could do to make the separation of variables relatively straightforward, Matt?
Just cross multiply.
Yeah, cross multiply gets it done here, doesn't it? A lot of times that will get it done. Sometimes it won't, but that's a good suggestion here. So we're going to write y dy equals 6x dx. And if you are keeping score at home, if you wrote that, that would be point number 1. So if you did nothing else, if that's all you wrote, you just ran out of time or just like didn't know what to do, that would at least get you a point, right? So that's good. But we'd hopefully be shooting for a little bit better than that. Once you've separated the variables, what's the next step? So let's do that. We're going to integrate both sides. Do this very carefully. I mean, you might look at these and think, yeah, these are easy, and I guess, yeah, they probably are, but take your time and do it right. What do you think? What's the antiderivative of y dy? 1/2 y squared. And on the right side, antiderivative of 6x? 3x squared. I'm not going to write the plus c yet. So it needs to be there. It really does. But I'm going to say at this point right here, I did my antiderivatives correctly. I'd say that'd be point number 2. It used to be, it's funny, it used to be like, even just like 3 years ago, if you put plus c, that plus c really needs to be there. It used to be that putting plus c on those correct antiderivatives would be worth a whole other point. It's not quite the case anymore. I'll show you what the third point would be. But you do have to have the plus c here. Like if you've done your antiderivatives, it really needs to be there right now. So the third point is this. And I'm going to suggest we do it in this timing, although there's ways to do it differently as far as timing goes. But I'm going to suggest this. As soon as you found an antiderivative, as soon as you found it, apply your initial condition. Okay? As soon as you find it. So right now, the antiderivatives are done. I'm going to apply my initial condition, y of 2 equals -2. This will help me find my c. Okay? I'll explain why I think you should do it right now. Here's what it would look like. 1/2 times y squared equals 3x squared plus c. Do you guys know which number goes where? Like y of 2 equals -2. Like which one's x and which one's y? X is 2, right? It's saying the input was 2, so that means x is 2 when y is -2. So I'm going to put the -2 here, and I'm going to put the +2 there. Again, this is a point where I've seen so many good students flip those around just probably by being careless. And so take your time, do it right. And I know you know what to do. Just do it right. So at this stage, if you had a plus c and you applied your initial condition in there, that's actually point number 3. Okay? So you got to have the c and you got to apply the initial condition. You got to kind of do 2 things for that third point. Finally, we need to find the c. So finding the c involves a little arithmetic. So this would be, let me ask you guys this. On the left side, would that be 2 or -2? It's +2, isn't it? Right? So -2 in parentheses squared is +4. And so half of that would be 2. On the right side would be 12 plus c. So I'm looking at this and I'm thinking -10 equals c. I still have not earned my 4th point. This would probably be a 4-point question. My 4th point would be to write the full solution. That would be, let's see here. Let me come over here to do this. I would have 1/2 y squared equals 3x squared minus 10. My 4th point is going to come from me solving for y. So here we go. What would be, oh gosh, what would you do to solve for y? Multiply by 2. Yeah. So it'd be y squared equals 6x squared minus 20. There's one little twist at the end. What's my final step? Square root. Please keep in mind that when you square root both sides, what symbol needs to be there? Got to be plus or minus. So plus or minus square root of 6x squared minus 20. And now listen, here is, hope you're paying attention because this would be really frustrating. I still have not earned the 4th point. Even if I stopped right there and I'm feeling really good, I know my algebra, I still have not earned the 4th point because the solution to a differential equation, amongst other things, has to be a function. And plus or minus something is definitely not a function, right? By definition, you plug something in, you're going to get the positive or the negative version of it. We have to pick plus or we have to pick minus. Any thoughts, any guesses on what we'd pick here? Just because you're a positive guy? I like that, Johnny. Anybody want to disagree with him? Yeah, Hannah.
The only way that y of 2 will equal -2 is if the outside square is minus.
That is correct. Does that make sense? She said the only way that y of 2 could equal -2 is if we pick the minus. Right? Because isn't the square root of something guaranteed to be positive? Yeah. Unless you put a negative on the front of it. I love your positivity, but in this case, we got to be a little negative. Yeah, so we would pick the minus. So maybe we could write a final step. Therefore, y equals negative square root of 6x squared minus 20. And that would be point number 4. Okay, so 4-point question. You look at it, you might think, gosh, man, the first 3 points, it was just like 3 steps, pretty quick and easy. That 4th point, we had to do a bunch of stuff. If you think about it, isn't the 4th point essentially just a bunch of algebra and a little tiny bit of calculus? And so that's the emphasis will certainly be placed on the calculus of it. So let me just give you a hint. Hannah explained it really well. Just give you a hint. If your initial condition's y value is negative and you're faced with a plus-minus choice, you pick the minus. If the y value is positive on your initial condition and you're faced with a plus-minus, you pick the plus. You won't always have to pick plus or minus. I mean, that'll happen sometimes like this one. But if it does, you just look at the y coordinate of the initial condition. That should tell you what you need to know. Okay. Any questions?
So would you get any partial credit if you had plus or minus, but you didn't solve those numbers?
Well, I probably would. I'd probably give you, if you had everything up there, but you stopped short of picking minus, I'd probably give you like 3.5 out of 4. The AP test would definitely give you 3 out of 4. They're scaled. I'm not scaling this. That makes sense? So they only deal in whole points. I would deal in half points because I'm not going to scale these and be like, oh my gosh, you're so close. Just do this and you'd be okay. But yeah, this would be kind of the standard grading for AP. Anybody else? All right. I don't remember what comes next, but I want to look. Let's see. Take a look at number 4. Okay, good. This is going to work out awesome. Okay, so yeah, number 4, a little tougher on the separation of variables. So I'll tell you what. Let's take just a minute or two here. Number 4, same instructions. Use separation of variables to find the particular solution. See if you can separate the variables. Might take a little more effort, right? So let's do that. We'll check it, and once we've confirmed that yes, you did separate the variables correctly, then I'll just let you guys see if you can run through it and get to a particular. Okay? Question. I don't have the answers memorized.
Well, like, so
What do you do with the absolute values? Is that what you're asking?
keep on dividing by 0.
No. Okay, that's what you're pointing at.
Like if I want to do this and so.
Okay, with that, please ask questions if you have any. But I would say separating the variables, the first thing I would do, do you see cross multiplying here? It just doesn't work at all, at least at the start. So I would add 5xy squared to the right side, so you get dy dx is equal to 5xy squared. If I try to cross multiply, it would get us going in the right direction maybe, but it's not going to get us all the way there. What were your thoughts? Like, how did you guys handle this separation? Yeah.
Divide the y over and then multiply the dx over.
So divide by y squared, multiply by dx. Yeah, you can look at it as 2 separate processes. I like that. So dy over y squared equals 5x dx. So at this point, you have earned the first point, right? You've separated the variables. Maybe one other thought before I just let you finish here. Did you guys flip the y squared up, or did you leave it down and think of it as ln? Has to be flipped up, doesn't it? It's not ln. So maybe you would write it as y to the negative 2 dy equals 5x dx. So if you got to that point, obviously you got the first point. You got separation of variables. I will let you guys try to finish all the way. You separate the variables. We want to find our antiderivatives. So finding my antiderivatives look like this. I would get negative y to the negative 1 is equal to 5/2 x squared plus c. As you guys know, I advocate for right here being the time when you plug in your initial condition, because I feel like if you do it right here, you're going to get points right away. I'm all about you guys, that's always the question. Do I need to know this for the test, or how do I get a good score? You want to know the answer? Plug the initial condition in right here. I might show you an alternative to this here a little bit, but I would do this. I would say y is 1 when x is negative 2. And I'd plug my initial condition in right there. And I would say at this point, I've probably earned 3 of 3 points. Or in some years, they might have actually given you 2 points for the antiderivatives, although probably not here. Probably 3 out of 3 right now. Got to do a little arithmetic. It's going to give me negative 1 equals 5/2 times 4, so that would be 10 plus c. I get 11 is equal to c. Good? Or negative 11, sorry. Negative 11. We okay? Hey, guys that are working on the potato question, hold off. You're doing good things, but I'm going to throw something at you. I want you to It's just beyond just being a processor of information. I want to ask you a question here in a second. So then if I did negative y to the negative 1 equals 5 halves x squared minus 11, I still have to find y. I still have to solve for y. We kind of did one like this, right? I could multiply through by the negative. I'd get y to the negative 1 equals negative 5 halves x squared plus 11. And then I could essentially flip and multiply over. But essentially, aren't I going to get y equals 1 over negative 5 halves x squared plus 11? Oops. That makes sense? Okay. I want to talk to you a little bit about timing. Okay. So can you guys, you probably have this written down. Maybe hopefully you have the correct answer written down. Can you remember the answer? And more specifically, can you guys remember the C? Remember the C. What I want to do is I want to erase all of this stuff. And I just want to present you with a problem that you might not be aware of yet. But if you do enough practicing, especially if you practice with somebody else, you might become aware of this problem. Let's say that somebody said, you know what, it's all well and good that you plug in the initial condition right here, but what I want to do is I want to solve for y first, then plug in the initial condition, and make the whole solving for this stuff in the end easier. So maybe somebody would do this. They would say, you know what, I am going to multiply through by that negative 1, and I'm going to get y to the negative 1 equals negative 5 halves x squared, and I'm going to say that minus c is really just some other plus c. So I'll just put this right here. And then I'll come over here and say 1 over y is equal to negative 5 halves x squared plus c. Notice I still haven't earned the third point yet, right? And that's why I wouldn't suggest doing it this way, but people might find this better. That's fine. So then I could write y equals 1 over negative 5 halves x squared plus c. Now I'm going to apply my initial condition. So my initial condition was when x is negative 2, y is 1. So 1 equals 1 over negative 5 halves times negative 2 squared plus c. So this is looking a little different, but let's see what happens. So 1 equals 1 over, this would be 10 plus c. I then maybe cross multiply, right? So then I would get, let's see here, 10, or negative 10, sorry, because I squared the negative 2. Negative 10, I'm just doing all kinds of crazy stuff with my, hang on, doing all kinds of crazy stuff with my arithmetic here. So then you'd get c equals 11. So then before we got c equals negative 11, right? And so I could see how someone would be like, whoa, 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 I got c equals 11, you got c equals negative 11. We could run into some serious problems if I took this and I tried to plug it back in here, right? Because that is not the step where I applied my initial condition. See how timing matters? So if I tried to do that, I'm invariably going to get a different answer than what somebody else got. But if I have correct timing, wouldn't I take this 11 and plug it in right here? That's actually when I applied my initial condition. So I don't necessarily advocate for what I just did right there. I advocate for what I did the first time. But just know, if somebody timed it differently, Hannah might get a C of 9, and Jake might get a C of 5, and Matt might get a C of 2, depending on the timing of it. But then if you hash it all the way out to the end, as long as you time it right, you should get the exact same final answer. Does that make sense? So let me just use hand motions. If you plug your initial condition in here, then here is where you should plug your C back in. If you plug your initial condition in here, but then plug your C in on this step, you're probably going to have a problem. So timing is everything. If you plug in here, plug back in here, and then finish. Okay? So don't go like halfway and then do your C and then plug it back in up here and then go all the way. I would advocate for the thing I did the first time just because it's consistent. If you just do it the same way every time, absent little silly arithmetic mistakes, like I seem to be having a problem with minus signs this morning, you should be fine. Did you have a question, Matt?
A little bit. What I did is I solved for the y, right?
Okay.
So I had negative 5 over 2 x squared plus c.
Yep.
And then I don't like fractions and denominators, so I
Yep.
just flipped that up. And then I got a c of 20.
You got to be careful with that because the c is part of the denominator, so you'd have to get a common denominator and add.
Right.
So it'd end up being like negative 5x squared plus 2c over 2.
Right.
you don't want to be super careful with that. Did you call 2C C, or did you leave it as 2C?
Well, maybe, because it's all a constant still.
Right, but then timing is everything. Like, when did you plug in your initial condition? Do you see how that could get all messed up?
I do.
So, you keep going with your question.
Well, I think I answered it, but if I didn't plug them in the right place,
Yeah, so like,
the equation's equivalent, it's still wrong.
because of the timing, right? Because are we talking about the same C? We could be talking about different C's. So, yeah, if you had 1 over negative 5x squared plus 2C over 2, we still, over 2, we still don't like that because, like you said, I don't like fractions and fractions. So then you maybe could write y equals 2 over negative 5x squared. And are you going to call that 2C, 2C, or are you going to call it C? It really doesn't matter as long as you stay consistent.
Okay.
So if I decided to put a plus C right here, then I apply my initial condition. I could maybe apply it right there. But then once I find my C, I'd need to plug it back in right there. If I plugged it back in here or maybe here, now we're talking about a different C, and that's where you're going to run into problems. Maybe you get like 22 or 5.5 or whatever it ended up being for your final C.
Okay.
Just when I say timing makes a difference, does that make sense?
Yeah.
Okay. Okay. And I guess maybe furthermore, do you see why I advocate for plugging the initial condition in right away? To me, you get the points, and you still might mess up the algebra, but at least you got the points, and it was easier. So, totally up to you. Okay.
So, but you plugged it in before you even before you even fully separated y.
Before I separated the variables?
Well, because like you left at negative y to negative 1, so like you don't need to have it. So
No.
It's exactly y equals.
Not at all. You
Okay.
can, because this statement right here, the initial condition basically says when x is negative 2, y is 1. So whether you have an explicitly solved equation or an implicitly messed up equation, kind of like that one is, when x is negative 2, y is 1, should make a true equation, should be a true statement.
Because like when you split up the points last time, like one of the points was the full like derivative, like or antiderivative.
Yep,
And so like that still counts as the antiderivative.
absolutely.
When you start plugging-
Absolutely. Yeah, you found the antiderivative. You haven't solved for y yet, but you found the antiderivative.
Okay.
Okay, great questions. Anybody else before we move on? So if you have not already moved on to number 5, I know that a good number of you have. If you haven't already moved on to it, please move on to number 5. Number 5 holds some twists and turns. Namely, I would say the main twist is how do you handle absolute value? That's going to be an important thing to think about. Okay? That should, if you already did number 5 and absolute value was never a thing, you should go back and recheck. See how you did, and we'll deal with the absolute value thing that hopefully came up for you. Separating the variables, are you guys getting the hang of this? Hope it's going okay. If you separate the variables on this one, I would divide both sides by y plus 1, so that would give me dy over y plus 1, and I'd multiply both sides by dx, giving me that right there. We good? Okay, so at this point I've earned the first point. This would probably be a 5-point question on an AP test instead of a 4-point question, because I think this next step you'd probably get 2 points for it. So we're going to do the antiderivative of both sides, giving me natural log of the absolute value of y plus 1 equals x cubed plus c. And this is where those absolute values that we've been trying to build this habit into, this is going to make a big, big difference here. So at this point, I've earned probably 3 points. I need to apply my initial condition, and here's where you want to pay super close attention. The initial condition is y of 1 equals negative 2. That means when x is 1, y is negative 2. So that would be natural log of negative 2 plus 1 equals 1 cubed plus c. Here's where this makes a difference. What's negative 2 plus 1? ln of negative 1 doesn't work, does it? But the absolute value of negative 1 is, gentlemen, 1. And we can do that, right? ln of 1. So ln of 1 would be 0. So 0 equals 1 plus c. And here's what I say. Here's why I said earlier you want to pay super close attention here. Here's what I want you to remember. Right here on this step, when I applied my initial condition, I want you to remember that the absolute values made a difference, right? The absolute values took a negative number and did its opposite, right? Found the positive version of it, right? So remember on that step, I'm putting a little star right there because I want to remember absolute values made a difference. Okay, so here we go. Let's finish this off. Of course, you guys can see that c equals -1. And so then maybe you'd come over here and say natural log of absolute value of y plus 1 is equal to x cubed minus 1. At this point, we're moving along pretty good. And we thought, cool, the absolute values did their thing. All I have to do now is, yes, sir.
So if you,
I had momentum, Josiah. Is this a question about future occurrences or past occurrences?
yeah,
Future or right now?
yeah.
Okay, go ahead.
So you plugged in the conditions, like if y.
The initial condition? Yep.
Yeah. So
Yep.
You plugged in the -2 for the y and then the 1 for the x.
Yes, sir.
What I did is I took each side. I didn't plug it in. I took it had above the red
You e'd
stuff.
both sides?
Yeah. Is that
Okay,
wrong?
you can definitely do that. I don't recommend it. Purely from a points perspective, right? I mean, seriously, like probably the most common question of my teaching career, it's either, is it going to be on the test? Or B, how do I get more points? And so I'm trying to meet you guys where you're at. I mean, ultimately my heart is I want you to understand it so we can talk about this. We should be able to work out fine. Let me do this. You're suggesting, let me do it like this. Josiah, you're suggesting let's branch this way when I already branched that way. Can I finish my branch and come back to yours? That makes sense?
Yeah.
Okay. Okay, so does that make sense? Josiah, you with me?
Yeah.
Okay, so let's finish this. We'll deal with the absolute values. Then we go back and say, hey, did Josiah mess up or is it good? So here we go. If we're solving for y, what would you do next? E to both sides. Okay, so e to this side. Can I show you a really common error? E to this, e to this, e to this. It's really bad math. That you cannot do. What you can do is you can do e to the whole left side and e to the whole right side. Maybe put that in parentheses, perhaps. The left side you end up with absolute value of y plus 1 is equal to e to the x cubed minus 1. And here is where people tend to struggle. They're like, oh my gosh, what do I do with the absolute values? So I want to remind you of something. Absolute values, basically the definition of absolute value is a 3-part definition. I think, you know what, I'll write it on the screen and then I'll erase it. So please don't write this down. The absolute value of x is equal to, it's 3 parts. I don't know if you ever saw this. The absolute value of x is equal to x if x is positive, right? If x is positive, the absolute values have no effect whatsoever. If x is 0, then the absolute value is 0. But what about if x happens to be a negative number? What's the absolute value of that? Negative x, yes. This is the one that always twists people up because they're like, whoa, wait a minute. I thought you told me that absolute values only yield positives. Well, they yield zeros and positives, right? Think about it. If x is already negative, how do you make a negative positive? You do the opposite of it, right? And so this is that situation. We're actually looking at this third case right here. Here's why I say that. Remember that step I started back there? Didn't the absolute values take a negative and turn them into be a positive? So when I get to this step right here, let me erase all this definition junk. When I get to this step right here and I want to say, you know what, I need to evaluate the absolute values, I need to remember that based on my initial condition, the absolute values made me do the opposite of the input, right? And so what I need to do here to evaluate the absolute values, I need to put negative parentheses y plus 1 equals e to the x cubed minus 1. Does that make sense? Because the absolute values took a negative and made them a positive, it's still going to apply because we're talking about that part of the function.
So if it was 0.
So if it was, what?
What if it was like the second one, where it's like if x equals 0?
Okay, you said, what if it was like the second one?
Like, remember your 3 steps? And when I was like,
Your 3 steps.
x is greater than 0, x equals 0. What about the x equals 0 case?
Like if the left side was 0, well then the absolute values had no sign changing,
So just
effects.
this one, right?
and so then it would just be the positive version of it.
Alright,
Yep.
so,
Yep.
So it'll only be negative if we change it.
If the absolute values caused a change in sign. Yep, exactly right. So then to solve this, I think I'll just divide the negative over. This would give me y plus 1 equals negative e to the x cubed minus 1. And then I would finish by subtracting 1. Be careful with your bases and your exponents. It's really easy for an exponent to kind of migrate down or migrate up or something. So the exponent is x cubed minus 1, and then there is an additional minus 1. So I'm guessing if you did not handle the absolute values very well, you probably ended up with just positive e to the x cubed minus 1. And that negative needs to be there because of the way the absolute values interacted with the initial condition. Okay? Kind of the same, like Hannah's reasoning earlier was, hey, the only way you could get a y of 2 equals negative 2, blah, 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 is if you had this. It's kind of the same reasoning. The only way the initial condition works is if you do that. Okay, question?
So we did it originally without paying attention to the absolute values at all.
So I went here and I solved the y, where he told me not to solve the y first.
Yep.
And I
Timing, no, timing's everything, Matt. So it's possible you could still get it right.
Right, yeah, and MIC ended up being negative 1 over e to the 1 to the
Sure.
which would be the same.
Yep. It can work out that way. Yep. So let's take a look at what Josiah said. So let me erase all this stuff, and let's see if we can make this work. And by the way, there's lots of different forms of these. You know, if you're adding exponents, you're really multiplying bases, and things could be flipped up or down. I mean, there's a lot of stuff that can happen here. So, like, whenever you take this quest, pray for me that I'll be able to understand what you did, because I might see 20 different tests, and I might see like 11 different versions of the same answer. So I'm like flipping things up or down and separating things or not. I mean, it can be pretty intense. So Josiah, let's see if this worked out for you. This is the spot where you did e to both sides. And again, I want to be really clear. You could definitely do this, but I don't advocate it. I don't think it's best. I don't think it's worst, because it could work fine, but I don't think it's best. Okay? So I'm going to go e to both sides like you said, and you can just tell me if I go off the beaten path here. This would give me absolute value of y plus 1 is equal to e to the x cubed plus c. And then what did you do with the absolute values? I'm kind of curious.
So that's when I plugged in the numbers.
Oh, you plug the initial condition in here.
Yeah.
No problem. Okay. So then when x is 1, y is negative 2. So that would be negative 2 plus 1 equals e to the 1 cubed is just 1 plus c. So negative 1, absolute value of that is 1. This would be e to the 1 plus c, right? So then to handle this, to get the c out of the exponent, we need to do ln of both sides. So ln of this side, ln of that side. That would give me 0 equals 1 plus c, negative 1 equals c. Jake, question?
Could you have done instead, like,
Hold on, let's not go down a whole other branch right now. Right? That just ends up being confusing because we're like, well, Jake said this other thing and Josiah did this and I'm confused now. Let me finish this. And if you have another question, we can do that. Okay, so Josiah's idea then, y plus 1 equals e to the x cubed minus 1. You still got to handle the absolute values. And maybe, I don't know if you did do this, but this would lead us to this, right? So what you did was not too much different. You still got to handle the absolute values, and because the absolute values turned a negative into a positive, you got to do the opposite of that expression to correctly evaluate the absolute values. So that might have been the difference, right? Still the same concept. We just did it at a slightly different timing. Okay. Follow up, Lee?
So we're only putting the negative outside because y1 gives us a negative.
And the absolute values turned that negative into a positive.
Right, so we gotta put that negative out there because we have a negative out there.
Yep. So if we had a whole different initial condition, who knows what it was, but let's say that on this stage it wasn't negative 2 plus 1, let's say it was like 5 plus 1, that's just 6, and the absolute value of 6 is just 6, there would be no need, in fact it would be incorrect to put that. You could essentially just drop the absolute values in that scenario because the absolute value of a positive is just the positive, and so you just would essentially drop them. Yeah. Okay. Other questions on that specifically? Jake?
so what if instead of doing ln of each side, you multiply the bases? So you said like.
Okay, slow down. Instead of doing ln of both sides, you're talking about this step right here? No. This
Yeah.
step.
Yeah, that step. When you're trying to get c out of the exponent,
Yeah.
Isn't like e to the x cubed plus c same as e to the x cubed times e to the c?
Sure.
Which is another c?
Yeah, I didn't know if Josiah was going there, but yeah, so here should all still work out. Like, so this is that thing I said earlier, timing is everything. As long as you time it right, you could get a variety of like intermediate c's that make it look like you have different stuff, but you actually don't. So if you did that, let's see, it'd be absolute value of y plus 1 equals e to the x cubed times e to the c, like you said. And e to the c is just some other c. So it's a different c, so we want to be careful with that. Be c times e to the x cubed. I just don't see a way that you could get away with not evaluating the absolute values and still get it correct. So I think maybe this would be the place where you'd have to plug in your initial condition. So if you did that, you'd get, let's see here, negative 2 plus 1 in the absolute values equals ce to the 1, right? 1 cubed. And so let's see here, this would just be 1 equals ce. So 1 over e equals c. Now this one, I'm really glad you asked about this because this looks radically different, right? Totally different. You're like, oh, surely this is wrong. I don't think it is. So if we go back to the step where we actually plugged in, which would be this step right here, I'm going to apply my c to that step. So this would be absolute value of y plus 1 equals 1 over e times e to the x cubed. Still not looking so good, but what's 1 over e? How could we rewrite that? E to the negative 1. So that would be absolute value of y plus 1 equals e to the negative 1 times e to the x cubed. And to parity off what you said earlier, if you're multiplying bases, what are you really doing? So it'd be absolute value of y plus 1 equals e to the x cubed plus negative 1, or just minus 1. We're in the exact same place, right? Now you just evaluate your absolute values, divide the negative over, same answer. So this really, I'm really glad you all asked about this because this illustrates the point where you got 5 people back at that back table. You might have 5 different intermediate C's, right? And Eliza's like, no, Alexis, you're totally wrong. And Bianca's like, nope, I think everybody's wrong. I got this right. And the truth is, Hannah's being quiet, Lainey's being quiet. You might all have different answers, but you might all be correct in the end. It's going to look a little different on the intermediate steps, but you might all agree. I don't know how we could get like 24 different or whatever we got in here. I don't know how we could get 24 different C's. We could at least get a handful of them, right? We could all say, no, you're wrong, you're wrong. No, we could actually all be right. You could be wrong, but it's feasible you could all be correct. You could be. We all make mistakes. Like I said, I'm having problems with negative signs, so maybe I'd be the one that's wrong. Do you have any other questions? These have been really good. No? Okay. So let's use our last little bit here. Where do we go? We're going to noon, right? Yeah, we go to noon. So let's look at the potato problem, if you would. If you haven't already done so. So this question, there we go. This question is actually from last year's AP test. And I just want to be straight with you. So I did not read this question last year, but this was probably the most commented on question. If you, for some weird reason, happen to be looking at the Twitter feed for AP, like right after the AP test last year, you'd have seen like profanity-laced tirades against the potato question, and all kinds of complaints about the potato question and blah, blah, blah. And people really struggled with it. Over 50% of the people on this question earned 0 points last year. And I think in dissecting it, I think there's a couple of reasons why. The global average, and we'll get into all this stuff later. So all of the FRQs are worth exactly 9 points. Every single FRQ is always worth 9 points. The global average on this was, we could look it up. I think it was less than 2. It was like 1.7, 1.6, something like that. As one of the very lowest average scores ever. So in dissecting it, I think there's a couple of clear reasons for that, and I wanted to kind of discuss those with you, and we'll kind of work through this one together. Take a second and read it. I'll read it out loud. You can kind of listen and read along with me. It says, at time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. So right when they take it out of the oven, it's 91 degrees Celsius. And the internal temperature of the potato is greater than 27 degrees for all positive times. So it'll never go below 27. The internal temperature of the potato at time t minutes can be modeled by the function h that has this differential equation dh dt equals negative 1/4 h minus 27. H is in degrees Celsius. H of 0 equals 91. So one of the first things I want to point out to you guys is it's really easy for someone to look at this question and really key in on this, and without paying any attention whatsoever to the instructions, just start separating variables, finding antiderivatives, and plugging in stuff to find C without any thought whatsoever to, hey, what did they ask? Did they ask me to do that? You're going to find that in one case, yes, they did, and in the other two cases, no, they did not. So let's look here real quick. Looking at A. Read it over. Look at B then. Once you've looked at B, look at C. Of those three, A, B, or C, which one is the only one that actually asks you to find the particular solution? A, B, or C? I'm just asking. Asking to look for keywords. This is a tough one. This is not an easy task I'm asking you to complete. Which one, A, B, or C, asks you to actually find a particular solution? C. It's C, isn't it? It's C. So look at A. A does not say anything about finding a particular solution. A says,
It's an approximation.
write an equation for the tangent line and then find an approximation. This is definitely not a particular solution. We'll do this one in a second. B says use the second derivative with respect to time to consider part A's estimate as being too high or too low. There's no wording in there at all that says find the particular solution. So I'll tell you what, a lot of folks did though. A lot of folks in A, they didn't pay any attention to the instruction. They just started separating variables and rolling with it from there. So the lesson, of course, is pay close attention to the instructions. Now, let's focus on C real quick. On C, let's talk about the language that you'd maybe see that would help you understand. So C says for T less than 10, somebody proposes a different model for the internal temperature of the potato. And that different model is G, and you got this other differential equation where G of T is measured in degrees Celsius. This is where this one gets tricky, and we actually talked about this at a meeting in December about they probably should have used a little different wording here. Can anyone find the wording that would be your clue that you should be finding a particular solution and separating the variables, all that stuff? Say again? I think more than one word is needed. Find an expression for G of T. Okay? Find an expression for G of T. So they gave you a differential equation, dg dt, and they say, hey, you know what? Let's find G of T. That's a really disguised way of saying find the particular solution. And this was unique. If you were bored one day and you wanted to just look back through all the old AP tests over the last 25 years, you would see mostly the phrase, find the particular solution is the phrase that's used. That's way more common. Find the particular solution given the initial condition. Sometimes it even says separate the variables. So this was really subtle, and I think that's maybe one of the reasons that people struggled. I think this was worth the last 5 minutes to kind of go through and dissect it and be like, what are they asking? Because if you don't know what they're asking, you don't know what to do. If I look at it, I'm like, I don't even know what they're asking. I don't know what to do either. That makes sense? So taking the time to underline, highlight, circle, whatever it is, keywords that say, this is what I need to do, I think that's a good step. Make sense? Okay. Well, then let's dive in a little bit. We have time for maybe one part or something like that. We'll get back around to finishing this. Not next time because we got the loop quiz next time, but next week we'll get back around to finishing this. I played it safe and just said next time. All right. So take a look at A. Stop, please. So A says write an equation for the tangent line. So from a perspective of what do I need to do? If you get to the end of this part and you don't have essentially like a version of y equals mx plus b, you've got an issue, right? Because it says write an equation of a tangent line. So literally this will be the equation of a line. Let me just remind you, what are the two things you got to have to write the equation of a line? Yep, the point of tangency and the slope of the tangent line. So it says write an equation for the tangent line to the graph of h at t equals 0. So t equals 0, that's my point of tangency, isn't it? But don't I need the other part of the point? I know that t is 0 is one part. What's the other part? When t is 0, temperature is 91, right? You see it up here. H of 0 equals 91. So that's a key piece here used in A. So my point of tangency would be, I'll just come over here. I would suggest you don't squeeze this in like I'm about to, but that's the only way I can do it on a video. So the point of tangency would be 0, 91. Okay, and then how do I find the slope of the tangent line? That's the point of tangency. How do I find the slope? Plug into dH dt. That's right, because dH dt is the slope of the tangent line. So this would be dH dt at t equals 0 equals, let's see here, if you plug in a 0, what do you get, 27 fourths? Okay. 27 fourths, 6.75, yep. Okay, so then my equation of the tangent line, it's okay if you use y's and x's or h's and t's. I think I'd probably use h's and t's here. So it would be h minus 91 equals 27 fourths times t minus 0. Does that make sense? Yep. Just using point slope there. Yeah, so I think, listen. Actually, let me complete this real quick. Or do you have a question?
I do.
Go ahead.
It says 1/4 h minus 27, so would you plug in the 91?
Oh my gosh. It's h minus 27. Thank you. Yes.
Yeah.
Thank you, Nick.
I was like, I did it wrong.
No, you didn't. Let's go back. Let's go back. Thank you, Nick. I don't know what I'm thinking. I'm struggling. Losing minus signs, plugging the wrong thing in. This will actually illustrate a good point. I'm sure this happened a lot. The input here is not a t. This is actually going to be really important in B. The input is not a t. The input is an h. So if you plug in a 91 for h, you get 91 minus 27, which is what? 64? And 64 times negative 1/4 is negative 16? Yes, thank you, Nick. I appreciate that. Negative 16, negative 16. There we go. Yep. Okay. You're actually, did I mess that up too?
No.
Okay, good, because I'm struggling with my negative signs and obviously not looking at H's and T's.
How'd you get -16?
Shh. Hey, guys. Okay, Alex is going to help you, Colin. Never mind. Are you guys okay with the negative 16?
Yep.
Raise your hand if you're not. I apologize for that. That's messed up. Do you understand the concept? Okay. It's Alpha Tuesday. So, hey guys. Hey, just tune her out. You know it's Alpha Tuesday. Use this equation to approximate the internal temperature at T equals 3. So here is where we'd actually plug in a 3 for T, right? This is going to be our approximation. So I would say, let me use a different color. Come over here and we'd say H minus 91 equals negative 16 times 3 minus 0. So negative 16 times 3 is negative 48. You add the 91 over, and you get 43. Okay, so we would say that H of 3 is approximately 43 degrees Celsius. Okay? Again, I don't advocate for trying to cram this between the lines, but that's the only way I can make this video. So, unwittingly, I hope that this lesson will stick. Unwittingly, I've shown you a common pitfall here, confusing T's and H's, right? Do you see why that's really easy to do? Like if you lose focus for a moment, you plug the wrong thing into the spot where you should have plugged in an H instead of a T. Pretty easy to do. Okay, don't pack up yet. I know that the Alpha Tuesday lady already made her announcement, but I still got a couple of minutes. You guys have any questions on A? Here's the big takeaway from A. Listen, 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 listen. It's so important. Because other than my little gaff with the H and the T, here's the bigger picture. Listen, here's the bigger picture. Do you understand that A never asked you to separate the variables? A never asked you to find a particular solution, yet that was done all the time by people taking this test. If you really stop and look at the words, you might say, well, gosh, why would anyone do that? Yeah, if you actually read the instructions, why would anyone do that? You wouldn't. But if you didn't read the instructions, like really read them, you know the concept, like I've shared it before, how you read like a whole page, you get to the bottom of the page, you're like, I got no idea what was on that page. You didn't actually read it. I struggle with that all the time. But if you get to the bottom of the page, you're like, oh, I remember in the first paragraph, so-and-so did this, in the second paragraph, this happened, in the third paragraph, blah, blah, blah. You actually did read it. Actually read it. Make sense? Be really, really careful that you're actually reading it. And then once you get beyond that, be careful with H's and T's, right? Just be careful with your inputs and outputs. Should be okay, right? The arithmetic is not that hard as long as you actually do carefully read. Probably 2 or 3 points right here. At least 2. So if you would have got those 2, you'd have been right. You would have been above the average right away. Kind of cool. We're not shooting to just be barely above the average, but you only completed 1 part, so that'd be cool. You're already above the average after 1 part.
So since it's you can put,
So-
instead of having the T equals 0 there, we can put H equals 90.
Okay, now specifically, what are we talking about? Are we finding the slope, or are we approximating?
No, I mean like on the left side of the screen where it says dH over dt.
At t equals 0? So that actually still applies, because when t equals 0, h is 91.
Yeah.
And that's what messed me up. I think somebody probably asked a question, or I just got distracted.
Yeah.
And I'm like, oh yeah, t equals 0, and I just went on with it. So you could, if you wanted to. Hey guys, hey. Jack asked a good question. I think it's worth you guys all hearing. Jack was looking at this. Watch what I circle, please. Jack was looking at this. He said, hey, is that t equals 0? Is that like wrong? It's really not. Because when t equals 0, h is 91. If you chose, instead of writing t equals 0, if you chose to write when h equals 91, that's just as good, right? It's a parallel fact. When t is 0, h is 91. You could have written either one of those two. Obviously, that one would probably help you not make a little mistake with h's and t's. But if you did write t equals 0, and then you plugged a 91 in for h, it's still justified because you know that when t equals 0, h equals 91. Okay, so I realize this is a little bit incomplete, right? We've only done part A, but I think that it was worth it for you guys to understand like what's expected and how the instructions go. We'll pick this up next week. Hope you guys have a good day. I'll see you tomorrow for the Loop quiz. I love that question.